Hello, check this out. This is yet another of the cool things that you can do with an Arduino. Suppose you had a switch or a sensor of some kind, and you have that somewhere in the world, anywhere in the world, and you want to be notified with a text message to your cell phone when that switch or sensor has been, well, let's call it a switch because that's what I'm going to do here, and you want to know when that switch has been turned off or on. Well, you can do that with a GSM module like that, and you can do a lot more interesting things besides just switches being turned off and on and stuff, but we'll look at that as a simple case to start with. So this is going to be my switch, and it's just a wire connected to pin 2 of this Arduino, and when I plug this into the ground, the other end of it into the ground, that's going to represent the switch being turned off. Yeah, off, because it's going to be pulled low. So I'll keep both of my hands in the shot here so that you can see I'm not doing anything tricky like sending a text message with another cell phone in the background, and it takes a few seconds, but we'll see switch was turned off. Well, it's a little bit hard to see maybe, but switch was turned off, and we can see what time it was done, and then yeah, so just to go the other way, we'll unplug the switch, and this should say switch was turned on in a moment. There we go. So let's have a look at what this thing is and how you can set it up and use it to do this and a few other more interesting things as well. There are a variety of these modules around, but this particular one came from IC Station. And I have to say a big thank you to IC Station because they actually provided this one to me free of charge for review slash promotion. You know how it is. And what we're looking at here is a search on IC Station. I just searched by GSM, so you can see that they have a bunch of other modules there as well. And this one that we're going to look at is the top left one on the list there. And it's just the cheapest one, as you can see, and I think this icon means that it's an IC Station branded one, so it's the only one on the list that's there, and that probably helps them to make it a little bit cheaper perhaps. But to be fair, it's lacking a few of the features that these other more pricey ones have, and you can see that some of them, like, oh, it's a little bit small to see, but they actually have an audio jack for headphones and microphones on there, so you can do voice calls as well somehow, I think. I'm not sure if you can do that with Arduino or what you would use it for, but this one doesn't have that feature, and it does have an antenna though. I actually saw another module similar to this but even more basic on Banggood, a little bit cheaper, but it didn't have an antenna connection, and it didn't even have any pins of any kind, so if you got that one you'd be stuck with some tricky soldering to get it up and running. So I think this one is a pretty good middle of the road if all you're doing is Arduino programs. So you're not going to be using this audio stuff, and yet you don't have to do any awkward soldering, or you don't have to figure out how to attach an antenna, and the price is pretty good. So let's have a closer look at this one, and I just noticed before that this special price of $25 is actually only going to be valid for another day, so probably by the time you watch this video it's going to go back to the normal price of $29. And the other thing I like about this is it's not a shield. So some of these other ones, like this one here, is pretty cheap as well. It's only $35 after the special finishes, but this is a shield. So I'm not a big fan of shields in general, and this one's for Raspberry Pi anyway, which I don't have. So I like it that it's a little bit more modular, or a little bit more independent of any particular Arduino form factor. So what is it? It's a 4-frequency capable GSM GPRS transmitter receiver, I guess you could say. Pretty small, only 24 millimeters each side. Oh, that's not right, sorry. What we're talking about here is the actual chip that's on the thing, by the looks of it. So this thing is only 24 millimeters. Yeah. Oh, where did my browser go? There. So I guess you can just look at the page here and I guess read it yourself. But I will draw your attention to one thing that can be quite important, and that is power supply current more than 1 amp. And apparently during transmission these things can use up to 2 amps of current. So you really need to have a fairly capable power supply to run them with. But for now, as you can see, I've managed to get away with just powering it directly from the 5-volt pin of the Arduino Uno. And that, actually, I have not tried it with the this external power connection here. It seems to be okay with USB. I've read some things on the net where people say it works great with USB, but as soon as they take the USB away and they try and power it with this one, then they run into problems. And I suspect that's because when you power it through here, you're using this voltage regulator here, which is a bit of a wimpy one, and I guess that probably cannot provide the full 2 amps that are required when you're doing transmission. So let's have a look at the physical side of getting this running, physical connections that is. There's really only 3 wires, apart from power wires, that are actually needed. So this little white plug in the base there just by the antenna is the power, and you're going to have the aforementioned 5 volts 2 amps coming in through there. And the only other wires that you need are a ground and an RX and a TX. So you do all of your communication over the UART style connection, and that's it. So took me a long time to get this running at the beginning, because I saw this here and I thought, well, ground, RX, TX. You would think that you just, plug your wires on there, wouldn't you? You would think that, you silly duffer. But that's not what you do. You need to use these other plugs over here, and I'll just jump over to the description page where, instead of trying to get my camera to focus on that plug section, I'll just show you what they are here. So this little bit here, that's the white power plug, and just above that you can see there's actually 6 pins there, so they haven't really drawn it here. I'll put a little line over here in the video to show you what I mean. There's actually 6 pins there, and they're laid out in this arrangement, this fashion, this layout there. So it says if you are using 3.3 volt interface Arduino, then you can use the 3V ones at the top. Otherwise, as in my case, I'm using a 5 volt Arduino, so I'm using the 2 in the middle, so that is OVR is the receiving pin, and then OVT is the transmitting pin. So the T would go to the RX on your Arduino, and then the only other one that you need is ground. So maybe we should have a look at that, but it's probably not going to focus, is it? Is it going to focus for us? Oh, there we go. So the 2 pins at the top are unused, then the 2 in the middle are RX and TX, and then the one on the bottom, or it's a bit hard to see there, but the one on the left on the base is ground. And over here these are going to ground, and then I'm using pins 7 and 8 because I have a software serial connection set up to use pins 7 and 8 there, but we'll have a look at that a little bit later on in the code. And of course, another thing that you're going to need is a SIM card. Fortunately, here in New Zealand, they are pretty easy to get. You can just get them for $5 over the counter. You just walk into a Vodafone shop. You can walk out probably 2 minutes later with one in your pocket, and very cheap. And a $20 carryover prepay will get you 500 megabytes of data per month. Well, you've got to keep paying every month, unfortunately, but you don't need to have a data plan to do the SMS that we just saw before, but you will need a data plan if you want to do HTTP connections, like looking up websites and web pages and so on. So another thing I should mention is that it may depend what country you're on and what cellular provider you're using as to whether this is even going to show up on their network when you plug it in and turn it on anyway. Because I actually had this given to me way back in September of last year, before I left Japan, and I tried it there and it didn't work. And apparently there's a serial number on here, IMEI number, and if that number is not one of the recognized ones that they've basically, if it's not one of the phones that they've sold you, they're not going to allow it to connect to their network. And I talked to the AU people in Japan, and they just didn't want to have any of it. So if you're living in Japan and you want to try this, forget it. It ain't going to happen. But like I say, New Zealand, a lot of other countries, it's really quite easy. And there may actually be, depending on what SIM card you get, again, this didn't happen to me in New Zealand, but SIM cards can have a password on them, so you may need to unlock that somehow, and I think you'll need to put that into your cell phone and unlock that with using a cell phone. I didn't have to do that, so I can't really help you with the procedure for that, unfortunately. But I think at least if you're in Australia, New Zealand, you're not going to have any issues with a Vodafone SIM card. Okay, let's have a look at what happens when we power this up, because there's a little LED here that gives us some information, and we can use that to figure out if we should start writing some software yet, or if we just haven't made any connection to the network at all. So I've disconnected the SIM card, and we'll have a look at what it looks like, or what happens when we fail to make a connection. So let's plug that in, and the LED comes on for a bit, and then we get a fast flash, which is about 1 second, maybe a little bit less than 1 second. And if it just stays like that, that means you have not established a connection to the mobile network. So let me just unplug that, and I'll put the SIM card in, close that, and let's have a look at what happens when we do establish a connection. We get the fast flash again at the beginning for a little bit, and then it sort of pauses, and then we have a slow flash, and the slow flash is about 3 seconds between flashes. So if you see that slow flash, you should be good to go. So from here we can start to look at the software side of it and try communicating with it, but I should mention also that you don't actually need an Arduino like I'm using here to talk to this module. You can also communicate with it directly using an FTDI adapter like one of these ones here, and plug your RX and TX into those connections there. You can see them, RX and TX and ground. So again, you just need the 3 wires, RX, TX and ground, on these to talk to them directly. The reason I'm not using these is because I'm eventually going to be using the Arduino to do something like I was doing with the switches before anyway, and also because I wanted to use the Arduino IDE's serial monitor to do the communication, and so I'm going to program the Arduino to just pass the serial monitor stuff through to this module, and this module will show us on the serial monitor what it's sending back to the Arduino. But I should mention, of course, that you can just do that with one of these. Depends what the software is you're using. If you're using Windows, you can use PuTTY or TerraTerm, and you can connect to one of these. When you plug it in, it should show up as a COM port, and then you should be able to talk to the module directly. So you don't need an Arduino for this, but of course, since we're going to be programming the Arduino later, that's what I have set up. Okay, so this is the Arduino sketch that I'm using to start with, and this is just going to let me type a command to the GSM module and have the GSM module return a response to me. Now, like I said, if you're using an FTDI adapter, you don't need to have this program. You don't need to have an Arduino at all. But this is necessary if you're going to do it with an Arduino. And all it is really is a serial relay. The Arduino will patch, is a fancy word, which is like pass, I guess. I got this off the net somewhere. And it will just pass that message through, and whatever the GSM shield says, it will pass back to us. So in the setup function, we just do a begin on each of those let me go back up here. We have a software serial port, and we're calling that GPRS, and it's on pins 7 and 8. So that's why I had the pins 7 and 8 connected to the GSM module before. And we have a buffer to store some incoming text and a count of how much is in there. And then in the setup function, we begin each of those serial connections at the baud rate of 96 bits per second, 9600 bits per second. And then the loop function is just this. All it does is it checks that there is something available coming in from the GSM module, and if there is, it reads it into a buffer, and then it writes it out to the serial monitor and then clears the buffer. And if we have typed something into the serial monitor to send to the GSM module, it's going to check if that's there, and it's going to read in what we've typed, and then Well, essentially it's going to just write that out to the GSM module directly. Now I have a little if statement here that says if one of the characters that I've typed in is an asterisk, instead of writing an asterisk to the GSM module, we're going to write this byte here, hexadecimal 1A, and this corresponds to a Control Z, or Control Z if you like, key press on the keyboard. So don't worry about that yet, but just keep in mind that every time we put an asterisk into the serial monitor, it's not going to send that directly, it's going to send a Control Z key press. So we'll get to that a little bit later. But if I just upload that to my Arduino and open the serial monitor, oops, it's over here. Let me just sort of arrange this a bit better so that you can see. Okay, there we go. On the right hand side I've opened up a web page which I found to be very helpful when I was doing this, because I wanted to do everything step by step manually before I tried to program the Arduino to do it. And I'll put a link in the description to this page, and we're going to look at the first of their tutorials, how to send SMS messages using AT commands. So if I just click on that, we'll see a page which lets us know what to do in the commands for doing this. So let's just have a look at AT commands in general, and the most basic command is just the command AT. What does that stand for? I've never really even thought about it until just now. But anyway, if we send that by hitting enter or clicking send there, we will see the GSM module will return to us. Usually it returns something along the lines of what you just typed, and then it will give you a status for the success or failure of that command as well. So what you want to see at this point is just AT OK. If that doesn't work, you may have to change the line ending type selection at the bottom of the serial monitor window. So there's a few different, well, you probably can't see this, but let's do this. So you can select some options there, and you'll have to, well, I found that I had to choose both new line and carriage return to get this to work properly. And of course has to be 9600 baud as well. So if the AT command like that does not work, you may find that if you just do a whole bunch of A's with a T at the end like that, that should also work and may be a little bit more successful, though I find that I almost never have to do that. But I read somewhere on a website, which I can't find at the moment, but apparently if you send a whole bunch of the same thing, it helps it to synchronize where the beginnings of each byte is in the bit stream that's coming in through the serial connection. So apparently AT with any number of A's is just as good as an AT with just one A. So that lets us see that we have a connection up and ready to use. Now, of course, that's a boring command, so we want to do something a little bit more interesting. And the first thing that's quite important to do is check if your GSM phone or modem supports SMS text mode. So we can do that by issuing this command here, and I'll just put that in and we'll see what happens. And then we'll look at it in a little bit more detail. So as you can see, it's just echoed back to me the command that I put in, and then it's told me OK. So if I just look at that again, the general structure of the AT commands is you have an AT plus, and then you'll have usually a 4-letter code for the command type, and then after that you can have an equals sign and then a value, which means that you're trying to set the value of that variable to something, which is what we just did. If you take away the equals and the value and you put a question mark there, that means that you want to query the current value of that variable. So if I send that, we can see it now it gives me 3 lines in the response. So it's echoed the thing that I said, and now it's giving me the value, the current setting of that value. So, well, it's 1 because we just set it to 1, but it could have been something else before. And then we get the OK after that as well. And the other thing that we can do is leave the equals there and put a question mark after the equals. So it'll be equals question mark. And what this is doing is we are querying what type of parameters we can give for that command. So if I try that, it's telling us here that we can give a value of 0 or 1. In other words, we could do like that, or we could do like that. So any other value would be invalid, I presume. So those are the three forms. You can query, you can set, and then you can also query the types of parameters. So what we've just done there is we've set the CMGF value to be 1, whatever that stands for. I didn't really bother to look at what these abbreviations are for. Alright, so moving along, there's a few things here that I found I did not need to bother with, and you probably won't need to bother with them too, so I apologize, but I'm just going to skip over them. I did try them out, and all of the values that they show there I already had set, so I didn't need to set any of them. So let's just skip down to something which is a bit more interesting, sending the message. And we can do that with this command here, although of course I have to change the number of the cell phone. So let's just put that in here, and I think the final letter here would obviously be send. I'm not sure what these first ones are. So what we're doing here is we're saying we're setting the value of CMGS to be this, and this also brings us into another mode where we start entering the text for the SMS. So let me just change that to the phone number that we're going to be sending to. Okay, so when I hit enter here, now we've set the cell number of the text, and as it says here, the modem will respond with a right-hand square bracket, or greater than sign, whatever you want to call that, which is exactly what we see there. So now we're in a mode where it's expecting us to type what we want to put as the contents of the text message. So you could do something like hello world, and then you need to finish that with a Control-Z character. And I found out that you cannot put a Control-Z character into the Arduino IDE's serial monitor. So that was the reason why I had, if I just pull this over for a little bit, that's why I had this little exception when I was typing things into the serial monitor. So if it encounters an asterisk, it will enter this Control-Z character instead. So what I'm going to do here is this is a test SMS message, and then I'm going to put an asterisk at the end, so that will close that message for us. So let me just bring my cell phone up so we can have a look at it, and when I click send, we get a response CMGS 21, and we have a text showing up here that we can look at, and it says this is a test SMS message. So that's great. And the response here 21, this is actually the ID of the message that we've sent. So if we want to refer to this later in order to delete it, I guess, I'm not sure what else we could do with it, read it perhaps, that's the ID of that message that is stored, and then we have an OK to say that everything was OK. So this is a test SMS message. Now let's see what happens when we respond to that message. I'll say thanks. Alright, let's say thanks. So we say thanks, and we send, and keep an eye on the serial monitor. Now we didn't type anything in there, but we just got a notification of something. So this notification lets us know that there is a text message that has just been received, and it is ID 2, and it has been stored on the SIM card. So let's have a look at that web page again. Where did that go? This one. So let's go back, and then we can look at how to receive SMS messages. So once again, I won't go through all this in detail because the first part of it is kind of similar. But I'll just point out that there are potentially other memory areas, at least on a proper cell phone. You would not always be storing stuff on the SIM card. You have other types of memory storage as well, and you can query which ones you have. But on the hardware that we're using, we're just using an Arduino GSM module, so we don't have a SD card or any of that other kind of storage anyway. So I won't bother with that, but I'll just go to the interesting part, which is listing the messages. So we can use this command here, at plus cmgl equals all, and I think I'll just paste that straight in there and we'll see what happens. Send. Oh, I need a bit more space here. Okay, so after I put that command, you can see I actually have two texts in my list, and the second one is the tanks that we just sent to ourselves, and that has come up with status record unread. Although what happens now that we've looked at this, it actually will be changed to status of read, and then we can see the phone number that it came from and the time. So if I just do that again, we should see that now both of them will be changed to status of read. So they're both read. And we can also list them individually. So that's ID2, of course, as we saw before. So ID2, when we got that notification, now we see there's an ID2 there. So it's all a bit primitive, the formatting. It's just comma-separated values, really, isn't it? So to read a specific message, we can do something like this, and well, they've actually got ID2 there for us, so I'll just use that. So that lets us just read a specific message, and we can also delete them like this. So there's just the last character changing in each of these commands there. So D, I guess, stands for delete, and that gives us an OK as well. So that text has now been deleted. This one here, by the way, was just one that I was doing before when I was testing for making the videos, so that's why that's there. Okay, so now that we know that, let's have a look at the program that was running right at the beginning of this video, where we sent a notification for a switch being turned off and on. I'll just go over this briefly. We have including software serial, and then we have the same thing that we had before. So we just have that on pins 7 and 8. And then I'm recording, there's only two variables really, there's a state and then a last state. So this is the state of the switch, and we need to record both of these so that we can tell when it's changed. And in the setup, we set pin mode for digital pin 2 to be an input, and it's input pull-up, which means that if we don't have it connected to ground, it will default to being pulled high. So that just means that we don't need to use a pull-up resistor. And then we check the state at the beginning, and then we set last state to be the same as state. So at the beginning, the switch is just, there is no state change. And then we do a similar thing to before. We start a 9600 board connection to the GSM module and also to the serial monitor. And then this is unnecessary, but I did this just so that I could see what was happening as I was programming it, because if we don't get a response to AT at the beginning, well, the rest of it's not going to work. And also found that we need to have a this is probably a little bit long. I found that 500 milliseconds is enough for the other things at the bottom of this file. It's not a big file, by the way, just in case you were getting scared. That's all of it right there. It's 50 lines in total. So I just put a little bit of delay there after that AT. And then in the loop function, all we do is we just, if there's any information or any text given to us by the GSM module, we just write that out to the serial monitor, just echo it straight out so we can see what it's doing. Then we set the last state to be state, and then we set state to be whatever the actual state is right now, so that then we can compare them. And if the state has changed, in other words, state is not equal to last state, then we send an SMS. And we don't want this to be running flat out, because we might get problems when we plug the pin in and we get an issue called bouncing, where the state of that pin goes on and off very quickly. So we don't want that to happen. So we just delay for half a second between each iteration of this loop. So then in the send SMS function, we have another couple of things, another couple of lines here that are not necessary. This is just so that I can see what is happening. And then we have the two, oh I'm sorry, yeah, two, well I guess there's only two commands really. This is probably not necessary. We could have done this once at the beginning. So you know what, I could probably just take these two lines out and put them into the setup function. It's not necessary to do it right here every time. But that just sets the mode to be plain text messaging mode. And then we give that a chance to finish. And then we do what we did earlier, which was CMGS and then the phone number to call, and delay again, and then we print out the actual message that we want it to send. So in this case we're going to say the switch was turned, and then if the current state is true, then it was switch is turned on, otherwise it's turned off. And then at the end of the message we have to once again send the Control Z character to close that message, and then we wait again. So let's oh yeah, we have to upload that to the, I just want to show you what's going on the serial monitor when we are running that, because I didn't show you at the beginning. So I'll upload that, and as soon as it finishes uploading I will open a serial monitor message, and we can see right at the beginning that's what happens in the setup procedure. And now let me just change the state of that pin so we can see it all happening all at once, hopefully. Right, and whoops, hold on, sorry. There we go. So switch was turned off, and you can see those messages happening on the side. So that gives you an idea of the time it takes to process this stuff. We couldn't really see it clearly at the beginning because I was kind of hiding that window there, but it takes sort of 3 or 4 seconds for that to get through most of the time. Now, as neat as it is to be able to do SMS text messaging to your phone from your Arduino like that, that wasn't really what interested me in these modules originally, because these modules are also capable of doing HTTP GET and POST requests to a web server, which is what I really wanted to try. So let's have a look at that, because I figured out how to do that, and it's a little bit more complicated than the SMS, but not much more complicated. So on the right side I have a website or web page, and this is just a little test page on my web server, and when we reload the page we'll see that it's just telling us the current time in UTC. I think it's GMT really, isn't it? So you can just see the seconds are changing there, and I'm going to use this as a test page, and I'm going to access this page using the GSM module. And at the beginning I'm going to do it again by command by command manually, like this. So I have my commands ready to go here, and I didn't actually find one single web page that really explained this very well. I had to sort of piece it together from other sources, but I'll just show you my cheat sheet that I have over to the side. So you can see this is the stuff we're going to be putting in. I'm just going to copy and paste it in for the most part, but you'll see there's not too much to it. So if it seems like it's dragging on, don't worry, the end is not that far away. Right. So what we need to do at the beginning is we need to say we want to start using HTTP commands, or the HTTP service, and that gives us an error. Now why would that be giving us an error? Okay, I figured that problem out. It seems that if you do HTTP init twice, every time after the first time you'll get an error in response to that. So it looks like you don't need to do it more than once. I think it would be nicer if it just said OK, really, because it's not really an error, is it? I mean, it's going to work. Alright, so the next thing that we need to do is I'm going to put this in here, and this is a slightly different form of thing than we've seen so far. And what we're doing here is we're saying we're going to set an HTTP parameter. So that's what this is short for. And the parameter that we're going to set is called CID, and we're going to set it to value 1. So it's sort of deferring the name we have a set of two parameters that we're giving at once. It's a bit hard to explain, but this is the first parameter that we're going to set, and then within that we have multiple parameters. So perhaps before I do this, let me just take this away, and I'll delete that, and I'll put a question mark here so we can query what this is, what this value is at the moment. And when we do that, we'll see that there's actually a whole bunch of things that are part of that. So it's a set of multiple parameters. Hopefully that should be clear when we see what we just saw, what we can see here. And the very first one, CID, is set to 1 already, because actually I'm not sure if it is to begin with or not, but maybe because I was just trying something before, that it could already be set to 1. So we don't really need to do this command right here. And just to see what happens if we do equals question, this will give us, so what we're doing here is we're querying what kind of parameters we can give to this http para command. So the response to that is to say the form for that command is you give a tag and then you give the value. So that's what we see here, tag value, tag value, tag value. So we can set any one of these sub properties, I guess you could say, using this format. So anyway, CID is set to 1. Sorry, I didn't look up what the CID is anyway, but set it to 1. Just do it. And the next thing that we need to set is the URL to look up, and we can see at the moment that that is empty, so we need to give that the URL that we're going to look up. And I just make this a little bit wider. So this is the URL that I had before, and again we have the command, and then we have the tag separated by a comma, and this time the value is a string, so we need to use quotes around the value as well. So when we do that, we should get an OK, and then if we do the ATCP question mark again, now we should see that in the URL field of those properties we have that URL set. So that is the groundwork ready for doing the actual HTTP connection. And to make the actual HTTP connection go, we do HTTP action equals, and then I'll just query this again and see what we get with the query before we try it. So this says HTTP action can be given a value of 0 to 2. And at this point I should probably show you another link that I was using. This is, what is this called? Sim900 AT command manual. I didn't really bring this up right at the beginning because it's a bit of a, it's not such a great document really. It's sort of hard to get around, and it's not very well laid out. But alright, oh there it is. Alright, so we can click on a link in here and we'll see. We can find plenty of info about stuff if we look hard enough. But what we're doing here is we're using HTTP para to set something, and we are, sorry, no, we're doing HTTP action, aren't we? Let's try that again. Action. Oh, Akiton. Alright, there it is. HTTP action. Here it is, HTTP action. So, like I say, this documentation is kind of, it's just hard to read. I don't know if anybody watching this video saw my other video about the U-blocks or the micro-blocks GPS module, but that had really good documentation. Blows this away. So anyway, the parameters that we're looking at here are 0 for get, so this is HTTP get, HTTP post would be 1, and 2 would be head. I haven't tried post and head, head should be easy, but I haven't tried post because I haven't figured out the commands to add post data, and I don't really need to. So I'm just going to use get, which is a 0. And so once again, this is the values here that we're matching that up with, 0 to 2. So let's just do HTTP action equals 0 for get. And that should, we just look at the current time here on this website, it's 3:43, and if I send this, now we get an error. This is an error, so if I just pop back over here for a minute, there is at least one thing that this documentation is good for, and it's looking up these error codes. So we've got an error 601. So what we're looking at here is we're being told HTTP action, the type of action is GET. The response code was 601, and the length of the data that was returned is 0. So this 601 corresponds to network error. So this got me quite stuck for quite a while until I came across a very helpful post here on Stack Overflow, of course. And it says that you need to set up the connection to the bearer, or the provider, I guess that might mean in more common terms. So there's a couple of commands here that I found that I had to use, and this WAP singular is what he used in his particular case. And I found that for Vodafone here in New Zealand, it is just Vodafone. Now I can't really help you with looking up what it's going to be for your particular cellular provider, but all you need to do is, so just to look at my cheat sheet again, this is what I needed to do at the beginning. I just wanted to show you that error before we fix the error. So in my case, I'm going to say Vodafone for that, and I'm just going to copy that in. So that'll fix that problem. We just need to say which access point, what is it, APN? What does it stand for? Access point or something? I don't know. Anyway, so with a bit of luck, that will say OK. And then the next one, when we do this, it takes a little bit more time to do this one. Okay, ready? Go. So it took a second or so to finish, but when we get an OK there, the rest of this HTTP action stuff should work now. So this documentation that we were just looking at mentions nothing whatsoever to do with SAPBR, so I don't know how that guy figured that out. Maybe this documentation I'm looking at is a bit old, but there is nothing in here. PBR. Holy shit, where'd that come from? Oh no, now I look stupid. How did I miss this? I must have typed PBR or something. BPR? Yeah, of course there's none of that. Alright, I take that back. So that is in the documentation. Okay, well, never mind. But suffice to say that now when we try our HTTP action equals 0 for get, now it says OK. Oh, it said OK before, but when we wait for a moment, this time the result is HTTP action 0 for get, and then 200 is a response code, which is, as you may know, it's just the OK code for an HTTP response. And then we have 35 bytes of data returned, which is that 35 bytes? It should be. Okay, so that worked. That's great. Now, where is that data? Well, it's stored in memory. It's not. It doesn't just pop up immediately after that, because that was sort of an asynchronous thing, as you might have noticed. We got the OK for the response for the request that we issued, the command that we issued, but then the actual response to the HTTP action didn't show up until a few seconds later. So it's asynchronous. Now, the command that we use to actually read back the data that was obtained is HTTP read, and I'll do this again so that we query what kind of parameters we're going to give to that. So the answer to the query is HTTP read takes two parameters separated by a comma. First parameter is a number between 0 and 318,000. Second parameter is a number between 1 and 318,000. So what we can do, what this is, I guess you have to look at the docs to know this really, but read, what we're doing here is the first number is the position in the data to start reading from, so I'm going to say that's 0, and then the next number is the number of bytes to read. Now we just saw that we have 35 bytes available to read from there, so I'll just put 35 in for now and hit enter there. And in the response to that command, we can see the text, current UTC 34700. If I just reload this now, we can see that it's 3:49. So I've been talking for 2 minutes and 5 seconds about this since we did it. But that's the data that we got from the website, very successfully done. If we try and access more than the available bytes, it doesn't matter, it just gives us say ATB read equals 0. So starting from 0, let's try and get 1,000 bytes and hit enter there. So even though I said I want 1,000, it's come back with the response HTTP read 35. So you could use that number to set up a buffer in Arduino if you were trying to read this into an Arduino. You know how many bytes you're going to need to read in after this. So it's nothing bad is going to happen by giving a number that's too large there. And just to illustrate how those numbers work, let's see if we start reading from the 4th byte and we read 8 bytes. This time we are given response of 8 bytes of data length, and it's ENT because that's starting from the, well, that's 0 indexed, so it's starting from the 5th character, really, isn't it? So it's ENT, and then we're just reading 8 bytes after that. So that's how that works. And I would imagine that because we have this value 318,000, that is the maximum data storage that this module is capable of holding for us when we read back an HTTP page. So if we let me just try something here. I'll put in the URL and I'll change that to the front page of my website, which is a little bit bigger than that test page. And then we'll try HTTP action equals 0 for a get again. So that's okay, and this will probably take a little bit longer because it didn't take too long. So we can see we had a response of 200, which is okay, and this time we have 13 kilobytes or so of data. And if we do HTTP read equals 0, so we'll read all of those. I'll just say 15,000 because it's not going to matter. And this will give us quite a bit of data back. So you can see this is the HTML of the front page of my website. Takes a fair while to read back over this slow connection, doesn't it? That speed, by the way, is about as fast as modems used to be back in the day. 9600 baud. That's how slow a web page would have come through. Glad those days are gone, eh? All right. Well, I think I've pretty much covered what I wanted to cover here. So the next step for me, oops, there's a bunch of crap on the side of my desk you weren't supposed to see. Look how tidy my desk is. So the next step for this is I'm going to try connecting a GPS module to this and read the GPS values and make a kind of a GPS tracker thing and see how that works. But that's all I'm going to do for this video. So thanks for watching. See you later.